All right, next up, we're going to use our new units of concentration and think of them in terms of stoichiometry problems. So remember, stoichiometry problems is anything that's related to amount of chemical quantities. You know, how much of this do we need to form X amount of that kind of thing. So there's nothing really new here. It's just an application of previous skills / knowledge. So if you were shaky with stoichiometry before, right, this is going to kind of come back to bite you in the butt. But really, you can catch up at any point and really do some practice. And if you're good at stoichiometry, hopefully this part isn't too much more complex. So we've got an equation. We're going to say that 2 KIs combine with 1 lead nitrate to form a lead iodide, which is a solid. So we've got a precipitation reaction here, and 2 potassium nitrates, which will stay in solution. So then our question is, how many liters of 0.115 molar Ki do you need to completely precipitate out the lead 2+ in 1.45 liters of 0.250 molar lead 2 nitrate? And again, this seems like a very, kind of complicated question, but it's just stoichiometry. We just need to really organize our thoughts and follow some kind of method, right? Oftentimes people just get, lost in the whole question, but really just try to pull out what data you need and try to start somewhere. And the best place you can start with these types of conversion problems is start with the thing that is not a conversion unit. You don't have to do this, but it's generally easier. And then after that, we just convert. So if we think about the numbers we have molar, that is a conversion unit. Remember, it's moles of solute per liters of solution. So it's comparing 2 quantities. And then we go to the next number, 1.45 liters. That's just a number. So that's where we're going to want to start. Right? It's just a liters. It's not a liters per anything. So 1.45 liters of our lead solution. And now we just start converting. We're at liters here. So think about what other values here have liters and are talking about the lead solution. It's only this one right here, this 0.250. So that would just be 0.250 moles of the lead nitrate, or the lead 2+, either way, it's the same thing, over 1 liter of solution. So we have the liters down on the bottom, that way they cancel out. And the 0.250 moles of the lead 2+ up top. Solution and solution can go ahead and cancel out. All right, so now we're at moles of our lead 2+, or our lead nitrate. Either way, it's talking about the same thing. So if you want to write it out as lead nitrate, that's fine too. And then we got to figure out what we're going to do next. What we want to talk about is liters of Ki, right? So that's a different compound. So what we're doing next is we're going from moles of A to moles of B. We're going from talking about moles of lead to talking about moles of potassium iodide. And whenever you're talking about moles of A to moles of B, we need to use the coefficients in our balanced equation. So if we take a look at our balanced equation, the lead nitrate has a coefficient of 1, while the potassium iodide has a coefficient of 2. So that tells us for every 1 lead nitrate, we need 2 potassium iodides. And so now at this point, we're talking about moles of potassium iodide. So what we want to be talking about, however, is liters of potassium iodide. And what we're given is the concentration of the Ki in terms of molarity. So we can think about that as 0.115 moles of Ki over top of 1 liter of solution. And if we think about that, that's perfect. That's exactly where we want to go, right? We have moles of Ki. We want to get to liters of solution. So we'll put 0.115 moles of Ki down here, 1 liter of solution up there, and then moles and Ki cancel out. And all we're left with is solution. Then we just go ahead and plug through the math. 1.45 times 0.250 times 2 divided by 0.115. We get approximately 6.30 liters of the solution. And that's our answer there, right? So again, this is just unit conversion. It's not anything new, but it is a skill that we want to really master. And the only way you can master a skill is through practice.